the next part, we are supposed to find the velocity at the position O and at the position B, given that the particle is released from a point C below level B. BC is given as 2L. That means when the particle is released, so you know that it will settle around here. Then what they do is they stretch out the particle downwards up to the level C, and this extension here from B to C is given as 2L. This length is 2L. It doesn't look like 2L, but just imagine it is 2L. Find the velocity at O and B. Now to find the velocity, right, so you can see that the center of this uh, simple harmonic motion is at x equals 0. That means this is the center, this point, center, right. So you know that the maximum velocity will be acquired when the particle is at the center. Find the velocity at O and B. Now when it is released from C, let's find out the amplitude. For amplitude, we can use this formula: V squared equals omega squared A squared minus x squared. Now x is 2L and the velocity would be 0 because we are releasing it from this point gently. So this means A will be equal to x. This implies A is equal to 2L. A is equal to 2L. Okay. Now you know the amplitude. So the velocity at O, you know that O is center, so you can directly write velocity at O is equal to A times omega. Omega is root G over L, root of G over L. So 2L times root G over L. So you get 2 times root GL. This is velocity at O. V at O is 2 times root GL. Then velocity at B. To find the velocity at B, you should know what x value is. What is x value? X would be minus L by 2 because you are measuring L x in this direction. So this would be minus L by 2. It will not make any difference. So velocity at B squared would be omega squared. A squared is now 2L whole thing squared minus x would be L by 2 minus square. This would be omega squared means G over L. Here you get 4L squared minus L squared over 4. So you get 15L squared over 4 G over L. Can get rid of an L here. Therefore, velocity at B would be root GL times divided by 2 root 15. Root 15 over 2 times root GL. This is the velocity at B. Right.